I am Jose. I work at the Bank of Spain, and the standard disclaimer applies that the views that I express in this presentation do not necessarily reflect the position of the Bank of Spain. So let me go there. Let me go into details. So as a motivation for this paper, there is evidence, empirical evidence on different channels in the economy that suggest an extension to both financial frictions and belief formation frictions. So Kaplan et al. In 2014, in an article, they studied different countries, the US, Canada, and different European countries, and they find evidence for financial frictions at the household level. And they summarize these frictions into being hand-to-mouth or not. And being hand-to-mouth implies that with whatever income you receive in a given period, you consume all of it. That is, you do not satisfy an Euler condition. You're just like an automat or a robot, and you eat everything that you receive. And these financial frictions at the household level are quite relevant across different countries and different time. At the same time, there is evidence on belief formation frictions, in the sense that there is forecast sluggishness, namely, when an agent makes a forecast, it is not optimally updated every period, but only sluggishly. That is, forecasts are sticky to priors. And there is evidence of this both at the household and the firm level, and also at the central bank level, although I won't exploit that dimension in the paper, by Koibinat-Gornichenko, Bordalo et al., and Brower and Colas, using different data sets, different surveys. And then there is a third piece of evidence by Holm et al. That suggests or provides evidence on the fact that after a monetary policy shock, if we divide the aggregate response into a partial equilibrium response, that is a response of GDP to changes in the real interest rate, keeping everything else constant, and the general equilibrium effects, that is what is coming in the response that is not directly affected by the real interest rate, they suggest that if you decompose in these two dimensions, the PE effects dominate in the first periods, while the GE effects, the general equilibrium effects, take some time to build and hit the economy. And this third finding is inconsistent with most of our theoretical frameworks, in which the P versus GE share is just a constant value. So, and I then, to shed light a bit more on these mechanisms, there is recent evidence on the relevance of these frictions for aggregate outcomes. In particular, financial frictions amplify monetary policy. Now, to think this, to give you an example, so suppose that there is an economy that is hit by a monetary policy shock. If this economy has a larger share of hand-to-mouth or a larger degree of inequality, GDP reacts more to that monetary policy shock than if it hadn't. And there is theoretical evidence of this seminal paper by Bilby, and then empirical evidence on this by Patterson here, and this Almgren paper in which I took part. Then, regarding the belief formation frictions, there is evidence that information frictions explain the responses to exogenous shocks, in the sense that they explain the initial underreaction to the monetary policy shock and the lagger reaction. This is why the IRFs that we observe to a monetary policy shock take a hump shape dynamics without needing to include any price indexation or habit formation in the model. So in this paper, the main aim is to understand the interaction between these two micro-founded extensions, these belief formation frictions and these financial frictions at the household level, and explain and shed light on some exercises. The first one is the amplification of monetary policy. I will study how does this amplification of hand-to-mouth agents depend on the degree of information frictions in the economy. I will explain the role of PE versus GE effects. And then if I have time, I will go to two exercises, namely the forward guidance puzzle and the role of belief shocks. And I will argue the model can, first of all, explain the forward guidance puzzle, or cure, if you may, the forward guidance puzzle. There is no such puzzle in this economy, and explain the persistence of belief shocks in the economy. Okay, so
can I just say one thing? Okay.
Oh, sure.
Because I hear people talk about monetary policy shocks, and in a lot of cases, I have no idea what they're talking about. Okay, when I think of a good example of a monetary policy shock, it would be 1980 and 1981. Okay, and it would be the Volcker disinflation. Okay, and what happened in 1980 was actually kind of similar to what is going on now, in the sense that they had raised interest rates. Okay, I started as an economist in 1981, so this stuff is very real to me. It looked like we were getting a recession in the U.S. Okay, in the sense that we got a couple of quarters that were weak, but not weak enough. And then Volcker raised the policy rate to 20%. Okay. And when people ask him why 20, he said he wasn't thinking of an Euler equation where people were going consumption growth is equal to the real interest rate and so on. He said bankruptcies. In other words, he was talking about raising the interest rate large enough to affect, people's, he wanted people to take him seriously, that he was doing something and it was going to have really, really big effects. Okay. So my question to you is this: how do you think about, if we go back to the way that Volcker thought about it, right? That he was trying to raise interest rates. He wasn't thinking in terms of PE, baby, but he was trying to get people's attention. Would you call that GE, or would you call that PE, like getting people's attention by raising interest rates up to 20+%?
Yeah. So let me go, because let me go in two parts to the answer. So first, in terms of what do I consider a monetary policy shock? So in the empirical framework, which I'm based on, a monetary policy shock is understood as a surprise in the interest rate that the market didn't expect. So it could very well be that there is a decrease in the nominal interest rate, but the market expected a further decrease, and that is therefore a contractionary monetary policy shock. So they can go in both directions. And how we in this paper, where we study the response of many European countries to monetary policy shocks, what we do to study this surprise component is the change in the future price of the price of the future, the derivative of Euribor rates, and in a very short window before and after the announcement by the ECB. So we interpret that as, if there is a change in that derivative, we interpret it as a monetary policy shock. Now, your second question.
Yeah? I'm confused. Okay, surely we can't define a monetary policy shock as something that's just unanticipated by the market, because we could have an unanticipated increase in interest rates, global interest rates, that would be driving up market interest rates. And we wouldn't say that's an unanticipated monetary policy shock. That could be driven by things other than monetary policy. So surely the monetary policy shock has to be with respect to the behavior of monetary policy, not just whether or not it's unanticipated or not. That's part of the confusion. Like when I listen to these people talk about this stuff, I'm thoroughly confused about what they're talking about most of the time. But And once you think about it that way, that means that you have to be really, really clear about what anticipated monetary policy actually is, which is the problem that I'm trying to talk about here. Do you agree with that? Or?
Yeah, so the identifying assumption that we have there is that because we study price changes in this financial product, the Euribor derivative, on a very short window, like minutes before and after the ECB decision. So the identifying assumption is that there are no other shocks correlated with this monetary policy shock in this tiny time framework. But then I think that the question that you raised, the second part of the question is much more interesting. Like what Volcker did, it was this call of attention. How do I interpret it? So in this paper, I won't speak to that, but I have another paper called Inflation Persistence, Noise Information on the Phillips Curve, where what I find is that I can explain an empirical fact, the fall in inflation persistence over time, through this Volcker episode. Basically, when Volcker raised interest rates in this way, he attracted attention. And this increase in attention, both at household and the firm level, is evident in the survey data. Yeah, like you can see that agents are much more aware of central bank actions after 1980 and after the mid-1980s than before. So what you find is that this increase in attention lowers the persistence of inflation through a framework, an information frictions framework that is very similar to this one. So this action by Volcker indeed changed the dynamics of the macroeconomy through belief formation. But again, in this paper, I will be completely, that channel will be completely absent. Okay, so let me then move to the model. But again, feel free to ask any questions, please. Stop me by. So in terms of the model has households, firms, and a central bank. Now, let me go first into households. So in the financial frictions dimension, the model is going to be a two-agent New Keynesian model, and I will be more specific about this, with a precautionary savings motive. So in this model, there are two types of households, and each type are going to face an idiosyncratic risk of not being able to access financial markets. That is, you wake up at a given point in time, and you don't know if you will be able to borrow in the next period. So in every period, the household is either financially constrained, which I denote as capital H, or not, which I denote as capital S for savers. If they are financially constrained, they're going to lose access to financial markets. That is, they're not going to be able to borrow nor save in this economy. And this risk of moving to one type or the other is going to take formally the form of a Markov chain, where moving from S to S, from T to T plus 1 is going to be done by a probability lowercase s, and the same for H. And 1 minus S and 1 minus H for their complements. And I'm going to assume that the lambda share of constraint agents, the share of financially constrained agents H, is going to be constant over time. So and additionally, the unconstrained agents, the unconstrained households, are going to be taxed at a rate tau, which is going to be reimbursed to the constraint. So there's going to be some redistribution in the model. So what is the benefit of doing this compared to standard Hank models? The benefit of doing this in this way is that the model can be solved in pencil and paper. You don't need to go to a computer and do a highly computationally intensive analysis. And it provides the precautionary savings motive. So it has the benefit of being simple, yet providing the principal mechanism in these highly computationally intensive frameworks. And then households are going to face another friction in terms of beliefs. So they're going to face noise information, which is based on Lucas 1972. Basically, agents, households, are going to face uncertainty on information. And because each agent faces uncertainty on information, they're going to face uncertainty on the beliefs and behavior of other agents. And I will be more clear about this. So in this model, there's going to be just one aggregate state of nature, which is going to be the monetary policy shock. And they're not going to be able to observe the monetary policy shock, but an imperfectly correlated signal of that shock. So what I'm going to assume more in detail is that households can observe their own private variables. They can observe the wage they receive, the savings that they make, the transfers that they receive from the state, but they're not going to observe aggregate variables like aggregate GDP, aggregate inflation, or aggregate or the nominal interest rate set by the central bank. And therefore, this comes to the last assumption of the financial the information frictions framework. A household I's information set is going to be the stream of signals that he or she has observed until today. So if you have this framework, you can write the following remark. Under full information rational expectations, that is, without belief formation, the economy behaves as if there is a representative agent household, where consumption or output today is equal to their expectations of a combination of the expectations of the real interest rate and consumption or output tomorrow. Now, the difference between the standard model and this framework is the red colored terms, this sigma here and this delta here, which are going to be, the first one is going to be the degree of amplification. This is what Bilby and this literature calls amplification of monetary policy. If this coefficient is greater than 1, any change in the real interest rate will affect more consumption than in a model in which the sigma is equal to 1, which is the case in the standard model. So that's why the literature argues that hang, or a larger share of hand-to-mouth agents, because this coefficient depends on the share of hand-to-mouth agents, react more to monetary policy than economies that do not have a large share of hand-to-mouth agents. The second one is the degree of compounding. In the earlier condition in this framework, there is going to be compounding because this delta is going to be greater than 1. That is, in this framework, the future is more important than in the previous, the standard setup, in which it is equal to 1. And this is precisely because of the precautionary savings motive. Households care more about the future because they want to save. They don't know if they will be able to save or borrow in the next period, so they want to save for that uncertain period. And this has the disadvantage that in a framework like this one, without belief formation frictions, this framework suffers from the forward guidance puzzle. That is, if you iterate forward this equation, because this delta is greater than 1 and there is compounding, any change in the real interest rate in the future will be more effective than if it takes place now. And this is what the literature has interpreted as a failure of the model, because the theoretical framework provides, suggests that forward guidance is far more effective than what it is in real life, and what Del Negro and other co-authors have documented. Now, this is the standard model without information frictions, only financial frictions. Let me now move to the information frictions framework. So I have this proposition in the paper. When I have the proof here, I can go through it. Let me explain it first, and if you want, I can open that one. So with dispersed information, if on top of financial frictions we have belief formation frictions, the economy behaves as if the average agent's best response is this one. Okay, my consumption today here depends on what I expect on the real interest rate, what I expect on the aggregate state of the economy, consumption or output, what do you expect on the future state of the aggregate economy, and what do I expect of my own consumption tomorrow? Where, again, this is related to a degree of amplification, which is equal to 1 in rank. So just before moving to the aggregate, in this framework, dispersed information can be very easily simplified to the framework without belief formation frictions. If there are no belief formation frictions, I can perfectly observe the aggregate state today. So I can perfectly observe CT here, the aggregate state of the economy today. And if you take this out of the expectation operator and you rearrange terms, you will get to exactly this condition. And sorry, and notice that in this case, the expectation operator has an I subscript, which implies that expectations will be heterogeneous by agents, depending on the stream of signals that he or she has observed in the past. And what you can do here is you can iterate this equation forward and integrate across agents, and you can write the aggregate GIS curve as a discounted sum of expectations of the real interest rate, an outcast of the state of the economy today, and a discounted sum of the output in the future. Where this expectation operator here, expectation operator of with a bar on top of it of any variable x, is just the integral over all consumers of their individual expectations. Now let's move to firms. Firms are standard in the sense that they don't face financial frictions, and they are as in the standard New Keynesian model. So in that framework, just the remark here, so under full information rational expectations, under no belief formation frictions, inflation today depends on the output gap and on inflation tomorrow, on expectations of inflation tomorrow. And this is the standard New Keynesian Phillips curve that we are all used to. Now, what happens if firms do not observe or face information frictions? So with dispersed information, the economy behaves instead as if each firm's response is this component. So my inflation rate today as a firm depends on my expectations or my nowcast of the economy, of the demand that I will face today, my expectations of the aggregate inflation rate today, because I care about what pricing decisions other firms are making to know how competitive my price is, and my expectations of my own prices tomorrow. Similarly, this condition under full information rational expectations, expectations of inflation are well known because we know the state of nature, and rearranging this equation, you arrive to this previous equation. So again, it's very easy to simplify to standard model. And second, if you iterate forward this equation and aggregate across firms, you get that inflation is a discounted sum of output expectations and inflation expectations, where this expectation operator with the subscript f in this case is just the integral of all firms' expectations of any variable x. Okay, so that was the belief formation part regarding households and firms. Now let me focus on the central bank. So the model is going to be fairly easy on that dimension. I'm going to assume that the monetary authority, the central bank, releases a monetary policy shock through a Taylor rule. So they set nominal interest rates based on a reaction function to inflation, a reaction function to output, and then an exogenous component, VT, here, which is, I assume, is going to take an AR1 process form, where which is persistent to the degree rho. And this eta t is going to have a white noise shape. So regarding the belief formation, as I said before, households and firms need to form expectations. They do not observe aggregate variables, but they form expectations about them. They care about them. So I'm going to assume that they're going to observe a noisy signal on the monetary policy shock VT. That is a signal received by agent I, regardless if it is a household or a firm, an agent in general. In group G here is going to denote the group like household or a firm. It's going to take this form. So instead of observing VT, the monetary policy shock, which is the only aggregate state variable in the economy, they're going to observe the monetary policy shock plus a noise component, this UIGT, which is going to be a white noise. So the households and firms are going to observe monetary policy shock, monetary policy shocks or monetary policy decisions from the central bank, but noisily. And I do this to capture the fact that that people in the economy do not perfectly know which is the nominal interest rate at each point in time, or aggregate inflation or aggregate GDP at each point in time. And I assume, or the theoretical framework is general enough to allow for households and firms being differently informed, because this UGT, IGT component has a variance that depends on G. I won't exploit this in the empirical and the theoretical analysis that I will show you later on, but the model is flexible enough to adapt it. And in this framework, if you have agents that want to form expectations in the way that they do, and if they face this information frictions framework in the ways that they do, noise information, optimal expectations are going to take the form of a Kalman filter. So for example, take this forecast of the variable VT. The nowcast of this variable is going to depend on my prior, that is, what did I expect of this variable to be yesterday at t-1, and another component that depends on the information that I have received today, this signal. And the weights 1 minus kg and kg are going to depend on the noise of this component. So if the piece of information, the news, if you want, the signals that I receive are very noisy, I won't weight too much the signal process, and I will weight more my own belief yesterday, my priors from the past. And as I said, this kg is going to depend on tau g here, and on tau eta, which is the monetary policy shock variance, and the persistence of the monetary policy shock. Now, as I said before, we need to obtain expectations. This is just a recap of the two equations, two main dynamic equations in the model, the output and the inflation equations, the DIS and the Phillips curve equations. We need to obtain expectations of these two objects, on these two objects, the output gap, inflation, and the real interest rate, through in some way, and they have to be consistent with this noisy information framework that I showed you before. So what I do to guess this, to find a solution to this, is I propose the following algorithm. First, I guess the dynamic processes of output and inflation. Now, given this initial guess of the dynamics of output and inflation, I compute the expectations using the Kalman filter, given these guessed processes. Once I have computed them, I insert these expectations into these equations. So I insert whatever I get here, and in other places, and obtain the implied aggregate dynamics. That is, how do output and inflation behave given those expectations that are based on some guesses? And then finally obtain the unknown coefficients of these dynamics processes from the fixed point, right? I check whether the implied output and inflation dynamics are consistent with my initial guess. That's how I get the dynamics in closed form. So I get to this proposition, the main proposition of the paper, at least of the theoretical framework. So in this framework, the equilibrium dynamics are just a system of two first-order difference equations in which the output and inflation are going to depend on previous output and inflation and the monetary policy shock. So if you see this, the equilibrium dynamics in this model look a lot like a VAR which is mainly what we usually assume, a VR1 up to order 1, which is generally what we assume in the economy, right? When we study it empirically. Now, something more subtle to analyze is that this matrix of intrinsic persistence or of persistence in the economy, A, is going to be, this is a 2x2 matrix that is going to be endogenous to this θ1 and θ2. And these θ1 and θ2 are going to govern information frictions because they are the roots of the characteristic polynomial of this matrix A. Now, to be more concise, what this implies is that whenever there are no information frictions, that is, the two theta's are equal to 0, this A is going to be a matrix full of zeros. So when there are no information frictions, yt and πt are not going to depend on their lagged values. And this is what I show in this remark. So under fire, no information frictions. And where these thetas are equal to 0, there is no intrinsic persistence. So this is full of zeros, and you only have that yt and πt are proportional to the monetary policy shock, Vt, with this matrix P satisfying the standard properties in the textbook model. So this was the theoretical framework. So what you get from information frictions is that accurate variables are anchored to lagged variables, and that there is an initial underreaction to monetary policy shocks. Now let me go to the applications and additional results.
Let me ask you a question.
For sure.
Could you please elaborate on the sequence of events? Because I saw that in the households model, they are uncertain about the contemporaneous consumption that they have. So is everything happening here at the same time? Or is there a sequence where the first shock happens, then the central bank reacts, and then the household reacts to the central bank or something like that? Or is it all at the same moment?
Yes, thank you. Thank you for that. So I assume that everything happens at the same point in time. Households are uncertain about the aggregate consumption or aggregate output in the economy, but they're not uncertain about their own consumption. Of course, in order to make a consumption decision, they need to know which is their consumption, their desired consumption, which was their consumption yesterday, what is their budget restriction, etc. So they know their granular conditions, but they do not know the aggregate ones. And this goes well with this literature on rational inattention, which assumes that it is less, or it is less complicated, let's say, to get information about my own local or granular conditions than the aggregate in the economy. That is the main assumption about the benchmark.
Perfect. Thank you.
Thank you. Okay, so let me then move to the applications and additional insights, but let me first discuss the parameterization that you will use for the analysis. So I do not estimate or calibrate the model except for only 2 parameters. So let me tell you how do I choose the coefficients. So I differentiate in this table between 3 blocks. The first block is the standard New Keynesian block, okay? And because I'm going to compare my results to the literature, namely Bilby 2021, which is a Hank model without information frictions, I'm going to take most of parameters from his paper. So basically, the discount factor is going to be equal to 0.99. The model is at a quarterly frequency. The Calvo probability is going to be 3/4. The IES is going to be equal to 1, just as the inverse free elasticity. And then the 2 inflation or the 2 Taylor rule coefficients are going to be set to standard Galli values. Bilby doesn't use them because he assumes that the real interest rate is itself an exogenous element. And the autocorrelation of the monetary policy shock here, which I'm going to assume to be 0.65, which is in the median of the literature. Galli, for example, assumes in textbook that it is 0.5, Linde et al. Assume that it is, and Cristiano et al. They assume that it is 0.8. So I take a median value in the literature. And then the monetary policy shock precision, I take it to be equal to 1, just as in the literature. Now, the second block is related to financial frictions. So I have to set tau rate. Remember, this is the rate at which agents are taxed. The rich agent or the non-hand-to-mouth agents are taxed and reimbursed to the hand-to-mouth agents. I'm going to assume that this is equal to 0.19, and lambda, the share of hand-to-mouth, is equal to 0.37. This is both based on empirical evidence in the US. And S, the probability of being constrained tomorrow, given that you're unconstrained tomorrow, given that you're unconstrained today, is going to be 0.96. So as you see, although I allow for agents to go to the other group, like being constrained or unconstrained, the process is quite persistent. That is, if you get to be unconstrained at some point in time, it is very likely that you will be unconstrained in the next future. Now, the last two, tau 1 and tau 2, these are related to information frictions. These are going to be the precision of the noise component that agents observe. And what I'm going to do is I'm going to calibrate them to match the Koibion and Kornichenko coefficient on the forecast error on forecast revision regression. But let me be more specific about this now. So we have to calibrate these information frictions, right? We have agents that need to form expectations, they observe a noise, and we want to be consistent with empirical evidence. So what the literature has done is mainly focus on inflation expectations from the survey of professional forecasters. Although Koibion and Kornichenko also show that the belief formation frictions that are prevalent for professional forecasters are also significant for other kinds of agents, households, firms, central bankers, etc. So what I'm going to do is, first I estimate the Koibion and Kornichenko regression for inflation, and I estimate this regression, which is the forecast error on the forecast revision. So let me be a bit more specific on this regression. So what we have on the left-hand side is the forecast error. So at each point in time, the professional forecaster is asked to give a forecast of this annual inflation. What do you think inflation will be in 1 year from now? This is the object that I take from the data. And I take the realization. So I take the realization of that forecast or the variable and take the difference. So this will be the forecast error. What was the mistake that the average agent or the average professional forecaster made at time t? And then I'm going to regress this object on the forecast revision. So what is the forecast revision? The forecast revision here is composed of two elements. The forecast at time t, so what does the average professional forecaster think of inflation at time t, minus what did the professional forecaster think about that same object at time t minus 1. So you can interpret this forecast revision as the change in the forecast, because this is the same variable that is being forecasted. So the change in the forecast after an inflow of information has come from period t minus 1 and period t. And I'm not the first to run this. Koibion and Kornichenko suggest this regression, and they find a positive coefficient. So what does a positive coefficient imply in this regression? Suppose that there is a positive forecast revision at any given point in time, so that agents think that inflation is going to be larger than what they used to think, right? Because this difference is greater than 0. So if this coefficient is positive, this implies that this predicts, if there is a positive forecast revision, this predicts a positive forecast error, which then implies that inflation, the realized inflation, is greater than the forecasted inflation. And then implies that even though forecasts moved in the correct direction, they fall short. Their forecast falls short consistently in trying to forecast inflation. And this is a very powerful result because it rejects the null of full information rational expectations. Because if agents have access to this information, they should not consistently under-revise their expectations as they do in the data. And again, I take this survey professional forecasters benchmark, but this empirical result is consistent with others in the literature. And then I compute the model implied coefficients. Okay, so there's an empirical result. What I do is I compute this coefficient in the theoretical model and match the two taus, tau 1 and tau 2, to be consistent with that estimate. And I have here this proposition, which says that the forecast error on forecast revision OLS coefficient is increasing in the degree of information frictions. So I define this coefficient as just the covariance of the forecast error and forecast revision and the variance of the forecast revision. That is the OLS coefficient that you have here. And I show that it is a function of tau 1 and tau 2 and other variables. I don't show it here. I don't show the functional form here because it is very ugly, but I have it in the appendix. And then lastly, I assume that since I'm only matching one coefficient, I'm going to assume that tau 1 and tau 2 are going to be equal. So households and firms are going to be equally informed. And they are calibrated to minimize the square distance between this coefficient in here and the model implied coefficient. So that's how the model is parameterized. Let me now move to the amplification and the set of results that I have here. So first of all, including hand-to-mouth households amplifies the response of output to monetary policy shocks. And this is a channel well discussed in the literature. And this is orthogonal to the belief formation structure in the model. So the proposed transmission channel in the literature is the following. So the central bank, first, the central bank, suppose that they decrease the interest rate. So there is an expansionary monetary policy shock. In this case, unconstrained households, because they're going to face an Euler condition, are going to increase their consumption. Second, because of this increase in consumption, and I'm going to denote this one, this first part of the channel, the P dimension. And this is what Douglas was asking before. So second, in this algorithm, the second one is that whenever these unconstrained households increase their consumption, aggregate demand is going to increase, right? They're going to demand more products, and wages are going to adapt to this new demand schedule. Wages are going to increase further. And these constrained households that did not react initially because they couldn't care less about real interest rate changes because they cannot save nor borrow, these constrained households are going to consume all the labor income change, all the wage increase, and they're going to magnify any initial change in consumption because they have an MPC equal to 1. They're going to consume everything. And this amplification of monetary policy is going to come from this constrained households change. And this is consistent with empirical evidence. So this theoretical transmission channel is consistent in the following sense. So first of all, Patterson shows that in a scatter plot here, that the MPC, or the aggregate MPC of a given demographic bin is increasing in the overall earnings elasticity with respect to GDP. So the larger is your earnings elasticity to GDP, the more volatile or the more sensitive is your personal earnings to GDP, the larger is your MPC, which is a channel required in this framework. And in terms of the aggregate effect, Algrim et al. Focusing in Europe instead, they show that the peak of the impulse response to monetary policy shock, the output gap, the output response to monetary policy shocks, is increasing in the share of hand-to-mouth by countries. And the same for the cumulative, the integral of that IRF. Okay. So there's the amplification in the benchmark model. Let's see how this amplification is changed by including belief formation frictions. So these are the IRFs of the theoretical model. in the standard model. So in terms of amplification, so first of all, this is the IRF. Sorry, this is the impulse response of output to monetary policy shock. And as you see, it is not intrinsically persistent. So it is only it decays monotonically with the monetary policy shock. There's an expansionary monetary policy shock, by the way. So whenever there is a 25 basic points monetary policy shock, output gap increases by 0.3 basic points and then goes back to 0 eventually. And what I do this here is I compute, I repeat this IRF for different degrees of hand-to-mouth agents, different share of hand-to-mouth here. And for every IRF, I take the peak effect of the output gap. And what you see is that the larger is the share of hand-to-mouth agents, the larger is the share of the output gap response. Second, now there are two issues on this. First of all, output increases by 0.3 basic points, or percentage points, which is inconsistent with empirical evidence, which suggests a much smaller response. And I'm citing here the Raimi's handbook chapter. And the second point at which this is inconsistent with empirical evidence is that the peak of monetary policy occurs on impact, whereas empirical evidence suggests a hump shape. So let's now compare these dynamics with the dynamics suggested by the belief formation framework, which are going to be drawn in blue. So in terms of the IRF, as you see, this is the beyond fire framework on the information frictions. You can notice first that monetary policy has a much smaller peak effect in the sense that it is just around 0.05 percentage points compared to the other value, which was 6 times larger. And monetary policy is less, the monetary policy shock provides a hump-shaped dynamics of the output gap response, which is consistent with empirical evidence. The peak is around 5 or 6 quarters after the monetary policy shock was released. And second, something to look at is that amplification here is reduced by 20% under information frictions. So what you see is that this, which was the amplification line, let's say in the fire framework, is smaller in the beyond fire. That is, increasing the share of hand-to-mouth agents still leads to amplification of monetary policy shocks, but to a smaller extent. And I will explain now to you why this is the case in the standard model. So let me go to what explains the different share of P versus what explains the amplification change. So what you have in this framework is that amplification acts through general equilibrium effects, but belief formation frictions lessen these G effects. So what you have is that the P dynamics are going to depend on first order beliefs, because what I expect of the central bank to do is irrespective of what other agents believe, because the monetary policy shock is an exogenous process. So what I believe of that process and what others believe will not affect the process itself. Now, general equilibrium dynamics are going to depend on higher order beliefs, because my expectations about output and inflation, for example, are going to depend on what other agents believe in the economy. So I'm going to decompose this output response into a P and a G effect. So the output gap here, the output response is going to be decomposed into a P. So whatever comes directly from the real interest rate change and what comes from whatever else is left, that is the general equilibrium considerations. So first of all, what I'm going to show you is the decomposition here. So this solid line is the total effect of monetary policy, and it is decomposed between a P effect and a G effect. And what I'm drawing here is the share of P over the total effect. So what you can show is that at the beginning, when the monetary policy shock hits the economy, the P share is very high and converges to the standard the no belief formation frictions share over time. So what is happening here is that the whole action in the model is going through the P dimension, whereas the G dimension is somehow muted. And this is important because this transmission channel that I showed you before, this amplification, the second and third channels that give rise to this amplification are all general equilibrium related. So because belief formation mutes this general equilibrium channel, that is what explains the smaller amplification of monetary policy when there are information frictions in the economy. And then this piece of evidence that I showed you, this decomposition of P and G effects, meaning that P effects drive nearly the whole effect in the beginning, is consistent with empirical evidence in Norway provided by Holm et al., in which they show that whenever a monetary policy shock hits in Norway, the red line, which is the direct effect or the P effect, and the blue line, which is the overall effect, what I call the total effect, nearly overlap in the beginning. And the P effects start going to zero, whereas the G effects or the total effect keeps moving. So let me now move to other interesting analysis. So the first one is going to be equilibrium determinacy. So we know, so there's this standard Taylor principle in the New Keynesian literature, which is that nominal interest rate should be raised at more than 1-to-1 with inflation in order to have non-explosive dynamics, in order to equilibrium to be unique, to exist and to be unique. So in this theoretical framework, as I said, equilibrium is unique whenever phi pi, the reaction to inflation, is large enough. So equilibrium is indeterminate when current outcomes depend excessively on expectations. What I'm going to show you is that information frictions, because they mute this the forward-lookingness of the model through as if myopia, are going to widen the determinacy region. So what I'm showing here is that here you have the in dark black, you have the determinacy region under the standard model without information frictions. So what you need in a scale that varies by phi pi values and phi y. So what you need is, suppose phi y is equal to 0 and the central bank does not react to output or unemployment. What you have is, in order to have an stable equilibrium, phi pi needs to be greater than 1, which is the Taylor principle that I just presented before. And as phi y increases, you can have moderate values below 1, but not too far from 1. Now, what you have here in gray is the additional determinacy region enlarged by the full information rational expectations. Okay, in this region in here. And the region here that remains is just the indeterminacy region. So what you have is that because belief formation frictions anchored expectations to priors, they are more dependent on the past and not so much on the future. And it's because it's this dependence on the future that makes the model explosive. This is what enlarges the determinacy region in this framework. And as I said, this is the determinacy region in the standard model, and there's the extended determinacy region in our beyond fire model. Now let's go to forward guidance. So as you all know, forward guidance was a policy tool enacted in the recent decade when nominal interest rates hit 0. So it's a non-conventional monetary policy instrument used when the standard one cannot be used. It's stuck at 0. And the theoretical framework, without information frictions, as I said before, suggests that forward guidance is very, very powerful. So if you promise an interest rate to give interest rates at a given level for many periods, it will have a very large effect that you promise it immediately now. So I do the following exercise. So the zero lower bound, there is a zero lower bound, that is the nominal interest rate is stuck at zero between period T and T plus capital T. And suppose that the central bank credibly commits to real interest rate change in T plus capital T as well. What is the effect on current consumption at each decision period? So what for each capital T? So in the FIRE framework, without information frictions, output can be written in this way, iterated forward, and the effect of a forward guidance shock, the effect of output today on a change in a given capital T period is going to be given by this. So because delta here, as I said before, is greater than 1, it will have this will explode with capital T, right? The larger T, the larger is the effect. Now, the empirical evidence, as I suggested, forward guidance is not as powerful as the theory suggests, which leads to the forward guidance puzzle literature. And, okay, how do we explain this, or how do we rationalize this failure of theoretical models? And I'm going to solve this in 2 steps. First of all, I'm going to show you that in the beyond FIRE framework, under belief formation frictions, the DIS curve can be written in the following way. It can be written as if it is a model with both habit formation and price indexation. So output today is going to depend on lagged values of output at inflation, the real interest rate, and future values of both output and inflation, where these expectations operators are the full information version expectations. And in a zero lower bound, given these dynamics, in a zero lower bound between T and T plus capital T, we're going to assume that the expected real interest rate is just equal to minus expected inflation, because nominal interest rates are equal to 0. And this DIS can be collapsed to these elements here. So in such framework, the effect of forward guidance here, the effect of increasing real interest rates in the future, given a change on output, are going to be given by this element here, where this theta here is going to be greater than 1. And it's the outside root of the polynomial, of a given polynomial, that depends on the coefficients of this equation here. Now, if this theta is greater than 1, you cure the forward guidance puzzle. The larger in the future, the smaller the effect will be. And this is what I show you here theoretically. So I'm comparing the standard model under delta equal to 1, so no explosive dynamics, but just constant, and the and the beyond FIRE model over time. So suppose that the central bank commits to a forward guidance shock in period T plus 1. This will be the effect on output today. Now, what if they promise to the forward guidance shock in 2 periods from now instead of 1? Then the effect will be smaller. So the more in the future the central bank commits to the forward guidance shock, the less effective it will be. And this is consistent with empirical evidence in Gallegos and others. Lastly, and this is the last exercise that I will show you, I will study a belief shock. And I'm going to replace, in this case, noisy private information for public information, because a shock to the noisy private signal will not have an aggregate effect in the economy, because they are idiosyncratic, they wash out at the aggregate. So I'm going to replace private for public information and obtain the impulse responses after a shock to the common signal. So now the model is going to be exactly the same, instead that the signal said that agents are going to observe is going to now depend on VT plus another different shock, which is going to be aggregate, like all agents are going to observe the same signal. It's not going to be idiosyncratic by agents. So what do you have in this framework? Here I'm plotting the IRFs to a monetary policy shock, the solid line, and a belief shock, a shock to this epsilon t. Notice that the shock to this epsilon t is purely idiosyncratic. I mean, it's purely transitory, in the sense that this object is not persistent. However, because agents cannot disentangle between the true monetary policy shock and some belief shock, some additional confidence shock, or you may call it, this purely transitory belief shock is going to have very persistent effects in the economy. It's not going to be a one shock in the economy. And what is also important, the policy rate reaction will be very different to a different shock. If the economy has been hit by a transitory belief formation shock, then the central bank is going to increase nominal interest rates to let agents know that this wasn't a true shock. It was just an overconfidence shock, if you want to call it. So here, as I said, purely transitory belief shock produces persistent effects. So now let me just conclude, and I'm open to questions if you have any. The main result of this framework is that amplification is still present, but the PE versus GE shift reduces the relevance of general equilibrium effects, shutting down partially the hand-to-mouth transmission channel that the literature has proposed. Secondary results, the Taylor principle is revisited, myopia widens the deterministic region, the forward guidance is possibly skewed, and transitory belief shocks have persistent effects on output and inflation. Then thank you very much.